You know what? This quadratic, I'm just going to quickly show you. You type that in, you realize it's a quadratic. It should be pointing down. I typed them both into my calculator, so this is going to be faster than I normally do it. If you have a bunch of equations, but you only want one or two to show up, just go to the equal sign and hit enter, and then it'll only graph the ones that are highlighted. This window is not good, so I'm going to go zoom 6. You know what? This will do. I see the intercepts. I see the vertex. It's all I need. If the province asks you to graph right off the bat, then obviously find the vertex, find the intercepts, do that on the side. I would personally say maybe keep reading and see if you need to find points anyways, and then come back and graph. Okay? So I will just show you here what the key looks like. And then I may just highlight things that are on here that are important. Okay, so do not extend the graph past. Okay, so if you see this, that is a minus half, right? You're going beyond what the graph is intended to go. So don't do what your calculator does. You have to kind of restrict the domain and range to the question. Label your axes. Equation, and I start with my y-intercept. The y-intercept is given to me by the equation itself. I know I didn't come around and check, I know, so I'm just going to trust you right now because I want to get going. So then intercept, I find the vertex on the calculator. All of the points that are important to me, I have them on the side here, so I use that to guide. So we were talking about a springboard, and someone is diving off of the springboard, right? So we obviously, this is the initial, and this is where you make contact with the water surface. So suitable to this context, we would say, because the height is height above the water, we just stay above the water. If it says with respect to the water, then the question would probably have to give us a bit more, because you can, once you're past the surface, this is negative, so they would have to tell us the diver reaches a low point, then comes back out. What kind of function do you think that would be? If I had a question like that, that'd be cubic, right? So it can morph into a cubic sometimes. But anyways, in this case, x-intercept, y-intercept, vertex, that's what I would look for. I'd be looking for the scale. I'd be looking for proper labels. So basically, labels, scale, and basically points. That's just for me here. So I basically give you one for each. So if you're missing a label, take off half. But if you're missing more than one label, take off a full mark for that category. For scale, that's a all or nothing for the province. So if you even make one small mistake, they take off a full mark for the scale. And then points, they should go where they belong. Close enough is good enough. However, if you can put it right on cue, then put it right on cue, right? Then you do look for that. So 3 marks for the graph here, if you did it. Explain the meaning of the zero or zeros of your graph given the context. Did anybody remember what that meant from last year? Zeros are the roots or the x-intercepts. It's this one right here. Okay? So it tells us, you could have Googled that, come on. Right? Google solves almost anything. It tells us the distance traveled, right, at a height of 0 meters above the water. Right? In other words, it's a distance traveled when hitting the water surface or something like that. That's what the meaning of that point is. It's the x-intercept. So maybe write that on your study sheet that zeros, like a zero or zeros, are x-intercepts. Okay. And you could have also messaged me. I would have gladly given you the answer if you're stuck ever, right? See, how far has the diver moved horizontally when they return to the same height at which they left the springboard? So the idea is here, I graph a line 2.77 horizontally, right? And I figure out here this time the horizontal distance traveled to return where you started, right? So basically you let y2 be 2.77, second trace 5, and we want this number right here, okay? You traveled horizontally for 2.41 meters. How high above the surface of the water is the springboard? This is your y-intercept, right? And that's a starting point. At time 0, you're here, so we're assuming that that is where the springboard is in terms of the height above the water. For the domain and range, we would look for, does your domain and range match the graph for sure? Like, that's something we would look for. So for my time, if you use interval, it starts at time 0 and it stops when you hit the water surface. For my range, you do get to a height of 0, and the highest you ever get to is 4.22. Right? That's given to me by the vertex right here. So the vertex it's a must right? From the vertex, that's where you got that point for. And if you do the set notation, if you use that, then you just have to make sure you use the variables in your equation. So x is denoted by the letter D, and so it's between 0 and 26 like that. And you have to have the squiggly brackets. And then for range, same thing. You use h because that is in instead of the y variable, and then you just go between 0 and 4.22. Okay. So this page is worth 3, 4, 5, 6, 7, and that's it right there. I didn't give you a backside extras, right? Just the 7. I do have extras on this one, but I didn't ask you for it, so you just have to worry about the 7. So give yourselves a mark at a 7. Make sure there's a mark on there. And let's go on to the next one, which was the giant slide, right? Make sure your name is on there as well. So in this case, I turn off the first one, I turn on the second one here, and I barely see something here. So I'm going to chase the curve on the top here. Window, Y max, let's go 50. Yeah, I see plenty. Now I'm going to chase the curve this way. So I'm going to go X max. Sorry. Yeah, there we go, 50. There we go. That's a pretty good window. You see the shape of it. We're good to go here. So that's what you would do to get it on your screen. And make sure you double check that if it looks like a straight line or something is off, you forgot the d cubed or the d squared or something. So you got to watch out for that. I asked you to graph right off the top. So what would you want to include? Y-intercept, x-intercept for sure. Then you would want to also focus on the local max and the local min. Just max min if that is better for you. Those are the points I would want to see on here. So if I show you the key, this is what it would look like. Okay. Obviously yours may look different if you use a different scale. 0 deductions, all right? So 0 deductions if that's you. So what I did is I found the y-intercept. You may use your calculator, but it's right off of the equation right here. Okay, that's my y-intercept. That's right here. Then I found the x-intercept. There's only, it says only the first 30 meters, correct? Watch this. The equation is only valid for a horizontal distance of 30 meters. So I found the x-intercept, but it actually doesn't make it into the graph, okay? Because it stops here at 30, it stops. So it begs the question, what is the y value at that point? So I did the work here, right here. Second trace 1, the value is 30 and the height is 2.43. So I'm going to label it here because it is important. It has to do with that initial statement there. So this graph is only valid until that point. Okay. So I'm guessing you're like dropping off, or there's like some sort of platform there that you go onto, and then you have to take the stairs down. Who knows, right? Who knows? So we have a distance in meters, height in meters. So, right, distance and height. I use my y-intercept. I did find a local min here. The local min is this point right here. I did find that high point there. That is right here. So I'd be looking for that. And my scale, because I needed to go all the way to 30, I found that going up by 5 so worked best here. And I did the same thing here and allowed me to have the 17 in there, no problem. And then I just plot these dots, and I usually go from those highs and lows and connect like this and make sure it's kind of curved at that point. And don't forget your equation. So again, label, scale, and points. See, when it's a decimal and you're off by a bit, we're not going to sweat it, right? But if it's like exactly 5, let's say it's 510, then we expect the point to be right at 510. All right, so that's the little nuance there. Yeah. We'll just take off half. I'm trying to think what they would do. I think if they make an explicit statement like that, I have a feeling they would take off 1, but we're just gonna go half today. You're still in the learning stage, right? So half. All right, so that's my graph. So yours should look something like that. And then here, any part, I made a change. I just want to make sure yours matches. Yours says no. Hold on. I just want to make sure yours matches because I'm always making changes. Yeah, okay, we're good. Any part that is 10 meters or more above the ground must be fully enclosed for safety. How far horizontally must the slide be fully enclosed? So again, where is the 10 line? I'm going to use my graph to help you with this one. The 10 line is right here. Okay, I don't think it's a problem to do this here because it's just right. This is the y equals 10 line, and so we want anything from here and up, like this stretch of the slide must be fenced in, right, or have an enclosure of some sort. So I find that intersection. Let me see if I can do this with you. I'm going to let y3 equal to 10. There you go. So it doesn't cross it here. You can investigate if you zoom in. It only crosses it here. So we only have to worry about this stretch. So second trace 5. Go closer to that one. Enter, enter, enter. And so that's 3.52 if you round it horizontally. So basically, this is your T2. This is your T1, so to speak. So you subtract these two. But this one is 0, so there's no need to subtract. It's just horizontally from the beginning of the ride till here, 3.52 meters horizontally needs to be enclosed. That's all you need there. How high up the slide? How high up is the slide 50 meters into the section? So we're basically asking, hey, if the distance horizontal is 15, what is the height? So we go use second trace value, x is equal to 15, and that is our height at that point. What's the domain and range? Here the domain and range, we go by the fact that it stops at 30 horizontally. So my x values go from 0 to 30. And vertically, because it stops here, I never get to the 0. So you must go 243, right? All the way to the highest point, which is the start of the slide. So it's 243 to 1758. Just be very careful which one is the highest point. Ask yourself that, right guys? Which one's the highest point? Look at the graph. If this graph did something like this, comes down and then goes way up and then back down, then this would be the one you would want to find to help you determine the range, right? So it's very contextual, it's very dependent on the scenario. Write an equation that would result in a slide with a higher launching point. And the key here is just anything back here that is bigger than the 17.58 that you had originally. Read carefully. It didn't give us any parameters here. If they had said we want the initial height to be 5 feet higher, or sorry, 5 meters higher than before, then you would make sure you add 5 to the back here, okay? So it's very dependent on the scenario here. So again, for the graph 3, then we've got 4. This is 2 marks on yours, right? Change it to 1. I wanted it to be 2 sections, but it didn't work out. So let's change it to 1 because there's not a whole lot of work you needed to do there. Change B to 1. C is also 1. So 3, 4, 5, 6, 7, 8. So this page is worth 8 marks. So make sure yours has an 8 at the top here with your name and last name. And I'll collect those. We'll collect them one at a time, all right?